from the Electronics and Computer Aided Drafting Design shops here at Norwich Tech in Norwich, Connecticut.
And today we're going to be making a dye-sensitized solar cell.
First thing we need are 2 pieces of conducting glass. For this demonstration we will be using tin oxide coated slides. Before you start, tape the top portion of the slide.
Mix the ethanol and titanium dioxide into a thin solution. At this point, the cell will not absorb light very well due to the white color, so we need a dark dye. Blueberry tea works, or if you're feeling adventurous, you can make your own dye from crushed berries. After making the dye, place the titanium dioxide slide in the dye. Let it sit for about 10 minutes.
While we're waiting on the dye, we need to make a cathode and electrolyte. The electrolyte we are using is solution in iodine and ethanol. Mix a very small amount of iodine with a beaker of ethanol, just enough to slightly color the solution. The cathode can be made by simply using a pencil to darkly color the conductive side of the other glass side.
So once the titanium dioxide slide is complete, remove it from the dye and let it dry. At this point, it should be dark, which will allow the cell to absorb light well. Once dried, place a couple of drops of the iodine solution on the dyed slide and quickly cover it with the cathode and clamp the 2 slides together. You can now remove the tape from the ends of the side and test the output cell using a strong light source and a multimeter. Alright, as you can see, we're going to test our completed solar cell. So we'll clamp the 2 allocated frames to each side. It's a rainy day outside, so we're going to use this artificial husky lamp as a light source. And as you can see, when we put it close to the lamp, we're getting approximately 220-ish, 215 millivolts. And so that's our completed solar cell.
Someday, these solar cells will help us power important things like homes, schools,
and light up Christmas sweaters.
I turn my camera on.